Hi there, and welcome to today's web seminar called Transforming Your Business with SAS Data, 5 Use Case Examples. And now I'd like to introduce today's speaker. So Dheeraj Ramella is the Director of Solutions Architecture here at VoltDB. He's in charge of all the Solutions Architecture team, and should you download Volt at any time, you'll receive emails from him as well, welcoming you to VoltDB and asking if you have any questions. And these emails are actually from him. He works directly with our customers to make sure they understand their goals, and then works even closer with them to make sure that those goals are achieved. So without further ado, I'd like to introduce you to Dheeraj.
Thank you, Sue, and thank you everyone for joining this call today. We're going to cover the positioning of data and its life cycle and how data is perceived at VoltDB, and how our customers have been able to put VoltDB to very effective use in handling their challenges around streaming data. When you look at where the world is today, in the past 2 years, we've actually generated more data than we have in the 20 years before that. And this is being driven by a lot of factors. When you look at the mobile phone factor, and the ability to do a lot of e-commerce online, and more importantly, the machine-to-machine communications and IoT and industrial IoT areas. So with what is actually professed to be a 10 trillion device world, you can imagine how much data is going to be flowing back and forth between various machines, and how to capitalize on leveraging this data to make smart choices and decisions and improve your competitiveness in the arena of your specific industry. So with that said, when you look at data, it used to be store and query and be able to make smart choices, and then that led on to the big data world where you look at a large amount of data and make smart insights and leverage those insights. Where the world is heading, though, is being able to make in-the-moment decisions. That is to say, when the data is created and has become a part of this universe, being able to take advantage of that fast data and make decisions that will improve your quality of interaction with your users, quality of decisions that you're making between machines, being able to serve your mobile applications as fast as you can, changing your billing into real-time billing so there's no reconciliation challenges. All of these become competitive advantages for the organizations that adapt fast data harvesting. Right. So at VoltDB, we look at data as belonging to two discrete camps. Of course, in real world, there are several other phases of data's life cycle, but on a broad brush terms, you could think of incoming data as the fast data area, and then the data at rest being the big data area. Here we're looking at, as an example, Hadoop being a big data. It could be very easily a traditional system of records database where you're just basically storing all your data. Or it could be a data warehouse where you want to run your predictive and prescriptive analytic models and learn something from what you have collected as data. Now, to operationalize that in real time is where fast data becomes effective. Because now you're actually able to apply the knowledge and insights that you have gained from big data on the incoming events, the real life events that are actually happening right now, and be able to make a decision that's relevant to that specific situation contextually. So Forrester, Mike Gualtieri from Forrester Research calls these insights as perishable insights, compared to the perennial insights that you would be able to extract out of the big data. The fast data insights are perishable because once it's gone beyond the point of context, it has become stale, essentially. So you want to tap into it while it's fresh and your decision and the action based on the decision is relevant. Okay. So this is something that we strongly believe that as time progresses, all businesses will compete on their ability to make decisions in the moment using fast data. So as soon as the data arrives, making a decision is going to differentiate a winner from a loser. what has actually changed, right? So when you look at the traditional data and the usage patterns of data, you are essentially storing the data, and when someone is interested in finding something interesting, then they go and query the data. So they do some analytics on it. But what is the outcome of that analytics? Is that just an insight absorbed by a human being, or is it something that needs to be operationalized to facilitate taking an action on that? That action component is the new thing, right? So when the data is coming in and you have understood what that data is, and now you're looking at a real-life event, comparing that event to what you have learned and the near past contextual data, and making a decision and acting upon that decision. That's the new mantra, so to speak. Several of our customers have put us to use in a variety of use cases, but we're going to discuss a few of them here. When you look at the broad trends of these use cases where fast data is immediately delivering value, you could think of hyper-personalization, where a customer or a subscriber of a telecom services is interacting with your system, and you're not just serving something to them, but you're serving something that's relevant to them exactly, and not just their demographic or their segmentation and a broader category, but instead you're hyper-personalizing it. Now, a second category would be a scalable data infrastructure that's built for real-time billing and resource counting. So resource counting, we'll see some of the examples in the following slides, but it could be how many readings came in, how much data transferred from one point to another point, how many calls were placed from one SIP server to another SIP server, and what was the least cost route that it was taken to transfer the data or those calls from one endpoint to another endpoint. All of these need to be counted and accounted for in real time to be able to facilitate real-time billing. Then you get into the other area of the telco use cases where you have a complex set of policies that need to be applied in real time. When an event happens, do you let that event continue to happen, or do you do a checkpoint on that, apply some policies, do a yes or no decision on that, and if it's a no, then act on it, right? So all of this kind of complex logic processing that needs to happen transactionally on each event that comes in. Then the fourth is where we're actually seeing a lot of interest come up, the IoT area, right? So it's become such a cliche that everyone wants to talk about IoT, and they say they are doing IoT. So what is IoT, right? So IoT is Internet of Things, but what is the point of connecting these things? If you cannot make a decision immediately based on the data that's transpiring from one end to the other end between these machines or between these things, so to speak, then you are losing out on the ability to maximize the value of that event's life cycle. So we will see some of the examples where we have actually been able to tap into that value. We might actually not have all of the use cases here, but we can talk through those use cases through this presentation. So when you look at fast data, we found three sets of common patterns of implementation, right? So when you're getting a lot of data, you want to do certain types of aggregations to measure some key performance indicators that indicate how your business is doing today and what is it indicative of. Is something failing? Is something getting better? Then be able to act on that insight in real time, be able to turn it around and say okay, let's do more of the good and less of the bad. And being able to do that in real time is one of the use cases. The other one is pipelining. So when you think of pipeline, it's not like a dumb pipeline, but you're actually able to leverage VaultDB as a data pipeline that's enabling you to enrich your data. Think of it as sessionizing, right? So an example that comes to my mind is clickstream processing. So each click of a user on a website means nothing just by itself. But when you take it from search to buy, it's a session. Now you have actually near past contextual data that you need to put together and make a smart choice on, and that's the sessionization. Then the third use case would be family of use cases, would be request response, right? So more often than not, when your data is coming in, along with the data comes a question, and this question needs to be answered exactly, correctly, and precisely, taking into account the last incoming piece of data, event or a message, and be able to stitch it all together and give a correct answer for a question that comes along. So let's look at some of the examples here. This is basically summarizing what we were actually discussing till now. We are not big data. VoltDB is not big data. VoltDB handles fast data, but what is fast data? Fast data is where the data is in its infancy. It's highly usable, but also highly volatile because it loses its value very, very quickly. Volt is founded by Dr. Stonebreaker, who is known as one of the superheroes of database world, and he has several of his friends and several of his students who together have invented several data architecture technologies. Dr. Stonebreaker won the Turing Award for 2014. Think of it as the Nobel Prize for computing, right? So now let's get into the crux of this presentation, where we are going to look at patterns of implementation and examples of such implementations that our customers have put us to use. So counting and balance keeping. So the common thread, again, is the high rate of ingestion. When the data is coming in really fast, it's not just new data that you just accrue and process later, but it's new data that's coming in that's changing the state of existing data. So how do we aggregate this data really, really fast? Like when I talk about materialized views, people cringe because coming from old traditional databases world, they look at materialized view as a periodic refresh job, right? So because if you run real-time aggregation on a disk-based system, it's going to crumble it. So what would happen is it's actually getting refreshed periodically, gets updated, these aggregates are updated periodically, and what that means is it's fresh for a very, very brief period of time, and it becomes stale very quickly. With Volt, you would be able to do these aggregations in real time as the data is getting ingested. We basically flipped the coin on that and said, instead of collecting the data and aggregating periodically, how about we aggregate as soon as the data arrives? So this is going to cost the ingestion a few microseconds, but your questions about the aggregated view of the data is going to be answered much faster. Typically, this kind of capability of VoltDB has been put to use in solving what we broadly call as the last dollar problem, right? So when you're running a campaign, an advertisement campaign, and you have an allocated budget for that, and you're going through the dollars in that budget, now when it comes to dwindling down all the way to the last dollar, and you are still showing impressions, you want to maximize that value elicitation. So being able to aggregate as to like what advertisements have been presented and how have they performed, and now how much have I actually already spent in real time at web scale, so to speak, and be able to make a determination when the campaign is running out of money helps you not have an overrun, underrun problem in your budget management. The accuracy is important in this case because being inaccurate has costed several hundreds of thousands of dollars for our customers over a period of time, and they wanted to not lose that money by presenting impressions that do not need to be presented anymore because that particular campaign has already run out of money. So one of our customers is AirPush. For folks that are not familiar with the advertising industry, AirPush is the second largest Android ad platform. So they used to have a 100-node MySQL cluster to address the performance challenges, latency challenges that they had. But what ended up happening is that it really started making their application logic very hairy, because it's not just an application logic anymore. Now it's actually having to manage where the data goes, on what shard it needs to reside, and how do I get access to that data, and being able to scale. If your data grows and you add more nodes to your sharded MySQL cluster, now the application actually has to do the rebalancing manually. So all of these challenges put together became a technological challenge that was still not meeting their business challenges, which is basically avoiding lost revenue and decreasing the opportunity cost while managing the bidding cost itself optimally according to what the campaign funds are still remaining. So when they transferred over to VoltDB, they were able to accomplish all of these needs on a much smaller footprint of a 7-node cluster, and they were able to still meet all of their business needs and have headroom for further growth as well. Another customer of ours is MaxCDN, and MaxCDN is a content delivery network organization. If I'm not mistaken, they were recently acquired by X5. And what MaxCDN does is they are transferring bits and bytes from their core servers to the edge servers, and their business is about billing how much data has been transferred, how many times the data has been utilized, the content has been utilized, on what edges and how far are these edges. All of these things led to having to manage several indicators and counters as the data is coming in and count them accurately for being able to bill in real time. So they transfer about 300,000 log records per second through VoltDB, and Volt actually addresses all of them and be able to update the aggregated view towards real-time billing in a fully consistent and accurate manner. They, when they were evaluating VoltDB, they were also looking at some open source options, and very quickly they started to realize that when you look at a stitched together open source infrastructure, each layer is a discrete layer of its own with needs to manage that layer all by itself. So the bottom line came down to, like, they would have needed 10 times more hardware than they needed with VoltDB to solve the same challenge with a stitched together open source solution. So not only is it actually delivering a greater performance than what you would get with a disparate multi-layer architecture, but also you're actually able to reduce the infrastructure costs as well. The next set of use cases we're going to look at is the sessionization. Sessionization is like what we talked about, the clickstream processing. So you know that a set of events make sense together. Each event by itself does not. So you would have a last known event, in which case when the last event arrives, you know that the session has completed. Now you can aggregate and put all of that information together in a cohesive manner, but in a more succinct and concise manner as well, compared to just storing raw data in your big data infrastructure and being able to process that. By reducing it to more meaningful data that's prepared for your analytics, you are able to leverage your analytics layer to do things faster as well. So Delta DNA is a partner of ours, and the business model for Delta DNA is being able to observe player behavior from their customers. Their customers are the actual game makers. So the game makers partner with Delta DNA to send the game session information to Delta DNA in real time, and when the data is coming in, Delta DNA now actually has a fast and big implementation together of VoltDB and Vertica playing together. While Vertica is doing all the segmentation analysis of the players, VoltDB does real-time determination of the experience level of the player, or the enjoyment level of the player of that particular level of that game, and what happened to that player. So think of a game where you're on level 15, and typically you should have actually, based on your historic behavior and your specific individualistic scoring, you should have been able to finish level 15 in 2 minutes, but it took you 5 minutes. Clearly, that was very hard for you, and you need to, retaining the player and keeping the screen in front of their eyes is what actually establishes a time period available for the game maker to cross-sell and upsell other goods, the in-app purchases, so to speak, right? So when you're in a game and you need this magic sword to slay the dragon, and you will be able to get to the next level, people who try several times or people who took more time than they would have typically taken to finish a level are more inclined to buy something from the game maker as an artifact that would facilitate them going to the next level. So these are opportunities that can be only monetized in the moment. If you lose it and if the player has left the game, they're probably moved on to another game. They probably stopped playing that game and they're just not interested enough in that game anymore. So to factor in all of these and be able to make a decision while the player is still in the game and present them an opportunity to continue to engage with the game is quintessential for game makers. And Delta DNA provides that service to the game makers by using VoltDB to make those in-the-moment decisions, so to speak. Event detection, we broadly call this as needle in a haystack problem. Think of denial of service attacks or something like that, right? So where you would be getting hundreds of thousands to millions of events per second, but not all of those events are interesting. But you do need to look at each event to make the determination if it is indeed interesting or not. So being able to filter those events out and finding the anomalous behavior, finding the interesting behavior, and acting on it. Now, this could be done on a single event basis or something like a CEP where you are collecting together a set of events that are contextually relevant and putting them all together in one frame and looking at it and making a decision as well. Excuse me. So this kind of event correlation is typically also useful in hyperpersonalization. So when you look at a specific user coming in, it's very similar to the gaming analogy, right? So when you're getting a user or a player or a caller for a telco company making several calls, each of these are generating several hundreds of thousands of events. But you need to look through those events, but also stitch together with the near past behavioral events and also their segmentation preferences, excuse me. So their segmentation, preferences, near past history, and what else kind of recommendations, what else would these users be interested in. Now putting these all together in a contextual manner gives you the ability to hyper-personalize the user experience, interacting with your system, your application, your mobile app. So Imagine is a partner of ours out of Australia, and they basically built a real-time decisioning platform that can be white-labeled into any kind of a scenario where you have several sources of incoming data, and you need to be able to correlate and collect them together, make sense between multiple streams of data, and be able to make decisions and choices, and then act on them. So what they do for telco customers, their primary target has been telco, but they're actually a platform, and you can plug and play in any industry where hyper-personalization is a need. Right. So in the mobile phone usage scenario where they have implemented this with telco carriers as a white label solution, they were able to detect plan usage thresholds and act on them in a very timely manner. One of the statistics that was shared by Imagine is the brevity of the time frame within which you need to make a decision and act on and show something interesting to the caller or subscriber to help them make an expedited decision. So from the time that you take the phone away from your ear, look at the screen, press N, and put it in your pocket, there is a window of 250 milliseconds that the subscriber is still looking at the screen. And you need to leverage those 250 milliseconds to make a decision that's contextual to the near past history and behavior of that specific caller, and what are the promotions available and campaigns that are available that this subscriber would be able to match and would find interesting, and then move the artifacts from some kind of a storage or content management system onto the screen. This leaves the database itself is about 2 to 5 milliseconds to make a decision and find out what will be interesting for the specific user. Real-time calculations. So when you look at real-time calculations, this is a combination of several complex things that need to be done on the data that's arriving, right? So it's not just the ingestion, it's not just the aggregation, but it's about ingesting the data, aggregating the data, and looking at what your new event did to that aggregate. Did it push it into anomalous area, and being able to act on that change in the aggregation. And you need to do all of these in a consistent, contextual, real-time manner, in a low latency manner, so that you are still contextual to when your response is going back to the question. One of our customers is a major financial bank. Unfortunately, we cannot share the name here, but the way that they use VoltDB is be able to get trade data and quotes data come in, correlate the data between these two streams and align them by timestamps, and calculate the national best bid and offer to make sure that they are within the compliance limits of ensuring that their traders are indeed seeing the NBBO. And on top of that, they're also doing risk analysis of the portfolio itself, and be able to recognize if a change induced by a potential trade would expose them to a higher risk level than they are permitted to according to the policies of that specific portfolio. So this could be, this is time series data for time-weighted average price, and volume, just the trade events themselves are triggering your volume-weighted average price movement as well. So by doing all of these calculations in real time per event of trade, and the quotes data coming in at anywhere between 30 to 60,000 events per second, you need to be able to scale, be correct, be consistent, yet be able to perform complex calculations. When you think of open source solutions to do this, again, it goes back to stitching together several layers. Each layer you add in your architecture is doing a specific job fantastically well, but when stitched together, each of these layers are adding an additional data transference, network latency, processing, and transformation of data from layer to layer. All of these costs get added in, which eventually pushes you outside of your potential latency SLA's window. It's the same customer again. This is the risk slippage, and being able to recognize what the incoming trade and the incoming quotes data correlated together, what does it do to my portfolio's risk levels? And how can I actually get the best available price by computing the NBBO in real time and comparing it to the ask and bid prices, and making a decision whether what price a trade should be executed at. Okay. So just to summarize these, VoltDB is specifically designed for processing fast data. There are several use cases. Primarily, what we are actually seeing, the industry leaders in utilizing fast data has been mobile, financial services. Mobile meaning, it could be telecom carriers, it could be mobile applications, wherever there is a large amount of data arriving within a short span of time. In financial services, it's typically the investment banking area, but interesting things are happening in financial services as well, where they are starting to adopt industrial IoT technologies and starting to see what can we do with things, right? So when you look at a customer walking into a bank and you know the customer's profile. And say, for example, the customer is handicapped customer, coming in, being able to send someone to greet that person directly, immediately, because internally someone got notified that, like, hey, here is a customer that would need additional assistance than a normal customer would. All of these actually enhance the experience of the customers themselves. And this is what is going to differentiate a successful organization compared to an organization that is failing to adopt to the newer technology and deliver relevant, modern services to their customers, and they end up perishing. So, excuse me. So, at the end of the day, when it comes down to what is it that VaultDB provides as an added value to what you're trying to do with your fast data, right? So it's a simpler architecture because VaultDB, for broad categorization, you can say it's a database, but what we actually do is simplify several layers by integrating them together into a single framework. Being able to ingest data using our importers, and you being able to process that data inside our store procedures instead of actually an extraneous system such as a streaming engine, you can incorporate that processing closer to the data instead of moving large chunks of data between a data store and a processing layer. You're able to do all of that inside VaultDB itself. Store, process, decide, and then export out. The export part now has two flavors to it. One is sending data to a downstream system like a data warehouse, such as a pipelining scenario. On the other hand, more and more of our customers have leveraged our ability to export notifications to message queues because this immediately notifies of an anomalous behavior or an interesting behavior to a downstream system, which is an actor, upon notification. So that basically concludes our presentation. So in case you guys are interested to learn more about VaultDB and how the fast data architecture is played out, you can download our ebook. Of course, if you're interested and you have an immediate need where you would want to consider VaultDB, feel free to download VaultDB. Of course, you will get an email from me, and that's just to basically check in to see if everything is all right and if we could be of further assistance to you.
Okay, great. Dheeraj, thanks so much for that. Pretty comprehensive overview of VaultDB and our use cases. And as a result, we have a bunch of questions that are coming in. A quick reminder to all of you that if you have your own questions or if you'd like to add more to what we have here in queue, feel free to click on the Q&A tab at the bottom of your screen and type that into us, and we'll try to handle as much as possible. But Dheeraj, to get right down to it, we have a few here already. So first one is, how does VaultDB compare to CEP systems?
It's something that we touched upon briefly during the presentation. VaultDB is a unified architecture layer, so it really drastically simplifies your architecture. When you think of data, what are the things that you need to do with the data, especially in the fast data realm? You need to be able to ingest the data. You need to be able to aggregate the data, process the data, apply some business logic to it, make a decision, and then be able to send the data over to the longer-term storage, such as a data warehouse or Hadoop. When you look at a CEP system, in fact, our own founder, Dr. Stonebreaker, invented Streambase back in the days when streaming engines were sufficient to address the challenges of streaming data. And he invented VaultDB because he envisioned where the usage pattern is going. The latencies are getting lower, the velocity of data is getting higher, and thus having two different systems and going back and forth and moving large chunks of data from a data store into a processing engine is only going to slow things down. By combining all of those features into a single product, meaning VaultDB, being able to ingest the data, being able to make the decisions, apply complex logic, store the data for querying, and being able to send it out to another data warehouse, it's very, very helpful because it cuts down on several of the latency factors.
Okay. We have one that just came in here. It Deirdre, what's the difference between fast data and streaming data?
So it's a blurry line, right? So streaming data has, the way we look at fast data is data that you want to act upon. Streaming data has several traits and characteristics that would delineate the outflow of where this data goes and how it gets processed. Think of sampling, right? So sampling, you don't need to act on each of this every single event. You could just basically collect the data, stream it through, and you can store it somewhere and then process it later on. You know, there's no urgency or need for immediately correct and consistent and precise decisions to be made on it. But the way we define fast data is where the data is coming in fast, but all of those data events are significant events. Think of the telco, where every single CDR is a significant event. The CDR is a call detail record, so it's indicative of who placed a call from where to where and how much this would actually cost into their plan. Being able to apply the rates and policies to those CDRs, being able to aggregate the usage to create a real-time billing profile. In fact, I actually have a cell phone plan with a very large carrier in the U.S., and at one point I actually wanted to check my bill, and my billing cycle ends on 25th, and 26th I wanted to see how much data I actually used. And I was kind of shocked, I guess, like because it was 2016, and I saw this window that said, we're still processing your data, check back in 2 to 3 days. And that was an eye-opener for me as to, like, you know, as a user, what is my experience of not being able to act on the fast data. So I hope that helped clarify a little bit.
Okay, let's see here. We have a few more coming in, and did you want to just follow?
I just saw a follow-up on the fast data and streaming data, and the example of streaming data is the real-time analysis, real-time flow of salinity, temperature, oxygen level of river. So these are actually good examples, right? So these are sampling data. So unless you want to act on this data, you will not be able to transfer into becoming a fast data problem, right? So it's just of data that's coming in. You can batch process it, you can immediately process it, depending on what you're trying to accomplish. If you're not making immediate decisions, yes, you could actually just stream the data in, store it, and process it later. So it all comes down to what are you trying to do? What is that application that you're building to deliver what value and be able to make sense of it.
Okay. Deirdre, here's the next one. It says, can I create a view by joining two tables?
That's actually interesting because we did not have this kind of feature until our recent release of 6.6. In 6.6, we started supporting a multi-table materialized view. So now you are not only aggregating at a single table level, but you're actually able to aggregate data from multiple streams that are coming into multiple tables and be able to connect them together and correlate them together in a single view. That's an interesting question. I'm not sure if I should answer it here or if we should have an offline conversation. But okay, I'll just read out the question. What about missile defense applications? So now it's fast data and you need to make decisions immediately, and that would definitely be a good consideration for VaultDB to be put to use. So in case we want to have further conversation, I'll just say poster, please reach out to me directly by email at dramala@vaultdb.com, and let's actually discuss in detail what the application's requirements themselves are, and if there is a possibility of VaultDB being a potential component of that solution. Is that okay?
Okay. Thanks, Dheeraj. Looks like we have a few more in queue, but we'll try to wrap it up here. So maybe we'll do it with this one. The question is, which aggregation use cases are more suited to stored procedures versus materialized views?
It's a really interesting differentiation of characteristics of aggregation. So materialized views, you would be able to analyze the data just by a simple SQL definition. You can just aggregate the data as soon as the data arrives. Now there are instances where you need to transform the data by applying some complex logic to it, and then store it as an aggregate and update it as new events that are relevant to that specific set of criteria comes into play. So that's where the aggregation from a store procedure comes into play versus materialized views, which would just aggregate it by SQL constructs. By applying Java logic, you can make more complex logic as part of that aggregation strategy pertinent to that use case.
Okay, and with that, it looks like we are coming up to the end of the hour, or we have a little bit more time left. But thanks so much for joining us this afternoon, and with Dheeraj for transforming your business with fast data. Any other questions, feel free to shoot us out a note at info@voltdb.com. And again, as a reminder, we'll be sending out the slides as well as the recording in a few days. And thanks so much for joining us. We'll catch you next time.
Thank you very much, everyone.